Welcome back to the deep dive. Today we are strapping in for a pretty high-speed sprint into the world of connectivity.
We're looking at active optical cables, AOCs.
Specifically, the DVIGear DVI-2525-AOC Hyperlight cable. And we should, probably unpack this because this technology, it solves two really massive problems for AV pros.
It really does. I think our mission here is to figure out how this one cable just smashes the old limits of distance and density.
Right.
We're talking about pushing uncompressed 4K at 60 frames per second over huge distances, like up to 100 meters.
And keeping the image perfect and secure the whole way.
Exactly.
So if we look at the performance figures, this is really where copper it can't keep up. We're pushing total data rates of up to 18 gigabits per second.
18 gigs. And it's doing it with resolutions up to 4K 60p in 4.4.4 8-bit color.
And for anyone listening, that 4.4.4, that's the important part. It means perfect, uncompressed color.
Zero compromise. It's what you need for a high-end cinema or, say, a command center application.
So how do they even do that? How do they get that kind of signal over that distance without crushing it down?
Well, what's fascinating here is the design. It's a hybrid. It's not just pure glass fiber.
Okay.
It's a very specific structure. You've got 4 polyfluorinated optical fibers, POF, that do the heavy lifting for that 18 gig data stream.
And the other part.
And then it's complemented by 6 traditional copper wires. That hybrid structure is really the secret sauce for getting a clean signal out to 328 feet.
And even though it's an active cable, managing all that data, it's incredibly efficient. It just sips power from the HDMI source, less than 0.235 watts.
Yeah. But does that ever cause problems, if it's pulling power from a source that maybe doesn't have the most robust supply?
It's designed to be a negligible load. I mean, the draw is so low that pretty much any modern HDMI source can handle it without a single issue.
So no need for a messy external power brick.
None at all for most installs. It's a major engineering win. Okay, so that covers the data side. But, great performance doesn't mean much if you can't physically get the cable where you need it to go.
Right. The installation nightmare.
Exactly. So let's talk about that. These cables are plenum rated. That's the ULCMP OF rating, so they're safe for air handling spaces.
And they're lightweight, super flexible, and have a minimum bend radius of just 2 millimeters.
A 2 millimeter bend radius on a cable like this, that is a huge relief for any installer. It's just so flexible.
It is. And for those really tight, just impossible conduits, they built in this brilliant little trick.
The connector.
The removable HDMI docking connectors. You just pop the bulky head off, and the cross-section that's left is tiny. We're talking 12.4 by 10 millimeters.
That's smaller than a lot of USB sticks. It makes pulling cables so much easier.
A genuine breeze.
And while that flexibility is great for installers, the tech underneath is also, it's designed for mission-critical, very sensitive applications.
And this is where the optical part really shines. Because the actual video signal travels over fiber. It's immune to RFI and EMI.
All that environmental noise.
Yeah, all the electrical noise in the environment, the signal just shrugs it off, giving it an extremely low EMI profile. That's the kind of clean security you need for, government, defense, high-stakes finance.
So to wrap it up, what this really means for you listening is that this AOC technology, it solves the bandwidth problem and the physical installation problem at the same time.
Both. In one simple, lightweight package.
A real game changer.
It is. But it does raise a pretty interesting question for you to think about. We know the video is transmitted optically, right, over the fiber.
Right.
But that hybrid design still relies on those 6 copper wires. They carry the essential handshake signals, the DDC, for EDATE and HDCP security.
The brains of the connection.
Exactly. So how does the engineering make sure that that crucial copper wire functionality stays perfectly reliable with no signal degradation over a massive 100-meter run? That's the real trick they had to pull off.